Power consumption within the mobile network is a huge burden for the mobile operators. While transitioning to more energy efficient technology is one approach, all other approaches should be considered if it will result in reduction of power consumption. In our TCO tutorial, we looked at power consumption, which is a huge part of OPEX. With 5G being rolled out, operators are busy supporting 2, 3 or 4 radio access technologies at the same time. This is a huge burden for them. This is also one of the reasons that they are keen to switch off at least one legacy technology, if not more. If an operator wants to switch off either 2G or 3G, the process can be complex and depends on a lot of parameters. We explained this in one of our earlier videos. Let us look at some energy saving approaches. The first approach is to switch off cells that are lightly loaded or not in use during off-peak hours. The main thing to remember here is that switching cells off should not create any coverage holes. Power amplifiers are the biggest source of power consumption for an eNode B. Cell switch off is essentially only the transmitter receiver being switched off, so it can be activated at a very short notice. The second approach is to adapt the transmission power based on the UE measurements. For example, in a busy area, when there are a lot of people and vehicles during peak time, the power requirement would be higher. During the off-peak hours, when there aren't many people or vehicles, the power consumption could be reduced. Another approach which is very relevant to 5G as well as to switch off some antennas in a multi-antenna system. The transmission schemes can be adapted using SIMO or MIMO or beamforming to achieve the maximum capacity with the minimum transmission power. Now at this point you are probably wondering, how does this procedure work? So let's have a look. During the normal operation, when all the cells are active, based on OAM or SON server input, an eNode B can inform the neighbor to switch off one or more cells. Remember that an eNode B generally has multiple cells under its control and not all of them have to be switched off. The information to deactivate the cell is sent in X2AP message, eNode B configuration update. The neighboring eNode B will acknowledge and move all the active UEs to neighbor cells controlled by other eNode Bs. Once that is done, it will switch the transmitter receiver for the cell off. The X2AP cell activation procedure can be later used to request the neighboring eNode B to switch on one or more cells previously reported as inactive due to energy saving reasons. No More Research white paper has a good explanation of the cell switch off procedure as shown here. In this example, a small cell or a home eNode B is activated or deactivated for energy savings. In this example, cell 2 and cell 3 are neighbor cells of the home eNode B, and we assume that UE knows the neighbor cells of home eNode Bs. UE moves to one of the neighbor cells of home eNode B. The second is the UE informs MME that it has moved to the neighbor cell of home eNode B. Third, MME notices that home eNode B is still not activated. It sends messages to activate home eNode B. Fourth, when UE moves to the range of home eNode B, it detects the signal from home eNode B and can receive services from home eNode B. 5. Then later on, UE moves out of the neighbor cells of home eNode B 1. 6. The UE informs MME that it has moved out of the neighbor cell of home eNode B1. 7. MME notices that there is no UE in the neighbor cells of home eNode B1. So MME sends messages to deactivate home eNode B1. When home eNodeBs are activated and deactivated, the impact on the neighbor cells should be taken into account. You should bear in mind that the procedure for activation deactivation for small cells or home eNodeBs are different from macro cells, as we saw earlier using the X2AP signaling messages. Here are some references for this topic. This was energy saving scheme in brief. With 5G being rolled out today, energy consumption is still an issue. The Chinese mobile operators and vendors Huawei and ZTE have all reported same approach being used for 5G in China right now. As the equipment becomes more advanced and energy efficient, some of these eNodeB or gNodeB deactivation times may be reduced, but this is still a good approach. In our final video in this series, we will look at HETnets from SON point of view. Thanks for watching and see you again soon. Goodbye.